Hello students, Kelly Daniels here, and in this video we will graph linear equations in two variables. In example 1, graph each linear equation and plot the intercepts. So if we are asked to plot intercepts, we want to make sure that we do that. Well, we find the y-intercept by substituting x equals 0 into the equation. So if we replace x with 0, 5 times 0 is 0, and the resulting equation is 2y equal negative 10. Dividing by 2, we have y equal negative 5. 0, negative 5 is the y-intercept. And always in your Cartesian coordinate system, x is your horizontal axis, y the vertical axis, so label those accordingly. If we turn around and substitute y equals 0, that'll allow us to find the x-intercept. So replacing y with 0, 2 times 0 is 0, and our resulting equation is 5x equal negative 10. Divide each side by 5 to obtain x equal negative 2. And the ordered pair, negative 2, 0, is the x-intercept. 2 points determine a line, so we've got what we need in order to sketch the graph of this equation. 5x plus 2y equal negative 10. If you wanted to check your work, you can always generate a third point and graph it and show that it does indeed reside on the line. I'm going to let you do a checkpoint on that one if you'd like to. In part B, we've got the equation y equal 2/3 x minus 2. Again, we want to plot our intercepts. Let's start with our y-intercept by letting x equal 0. Now, in your equation, if x is 0, 2/3 times 0 is 0. And we have y equal negative 2. When your equation is solved for y, you can always see the y value of the y-intercept sitting out here as the number only term, okay? Negative 2 is the y value of the y-intercept. Okay, that's our y-intercept. Well, let's turn around and substitute y equals 0. So in our equation, if y is 0, we've got 0 equal 2/3 x minus 2. Let's add 2 to each side. And then let's multiply each side by 3/2, which is the reciprocal of 2/3. Multiplying reciprocals cancel out, gives us our coefficient of x as the number 1, 1x. On the left-hand side, our 2's divide out, and we've got 3. X is equal to 3. 3, 0 is our x-intercept. Connect your points to graph your line. And that's the equation y equal 2/3 x minus 2. Now, one thing to mention here, if you wanted to find a third checkpoint, choosing x values that the number 3 will divide into will allow you to avoid fractions. For example, another good choice for x would be 6. That would give y equal 2/3 times 6 minus 2. 3 divides into 6 evenly 2 times. 2 times 2 is 4. And 4 minus 2 is 2. And let's just check and make sure that the point x equals 6, y equal 2. It's kind of sitting right here where I've already written coordinates 3, 0. But it does look like it's going to sit right there on our line. And that's just a good way to check your work and make sure you've made no silly mathematical errors. Well, as we talk about finding intercepts, to find the x-intercept, let y equal 0 in the given equation and solve for x. To find the y-intercept, let x equal 0 in the given equation and solve for y. Now, in example 2, graph the linear equation of the form ax plus by equal 0. Okay, so here's an equation that's going to have x and y intercepts at 0, 0, the origin. And let's make note of that. So in this equation, if we replace x with 0, okay, we have y equals 0. Now, if you do this, if you turn around and in the equation replace y with 0, okay, that y term disappears, and we've got the statement 2x equals 0, dividing by 2, x equals 0. So that's just going to generate the same point that is the origin. So don't do that, okay? That's usually the first thing that students do, and then they're like, oh my gosh, I can't graph this. Well, we've found a point. We need a different point. So choose x or y to be something other than 0. Like maybe let x equal 4. So in our equation, if x is 4, then 2 times 4 plus y is equal to 0. 8 plus y equals 0. Y equal negative 8. And let's plot our points. 0, 0 is the origin, and that's both the x and the y intercept. And let's plot 4, negative 8. 4 on the x-axis, down 8 along the y-axis. 2 points determine a line. Let's connect the points. And if you'll use a straight edge, a ruler, or driver's license, student ID, business card, that'll help you be neat with your work. And here we have a graph of the equation 2x plus y equals 0. Example 3, we're going to graph some horizontal and vertical lines. Beginning first with the equation y equal negative 5. Now, don't make this too difficult. There's really not a way to plug in values, but let's just think about this. We're going to find all points that have a y value of negative 5. For example, as we think about our y-axis, simply find negative 5 on the y-axis, x equals 0, y equal negative 5, and plot that point. So there's one solution, okay, a point with a y value negative 5. Then find another point with a y value of negative 5. So how about x equal negative 4, y equal negative 5? Notice I'm not substituting values. I'm just thinking my way through this, okay? Let's find another point with a y value of negative 5, like maybe 10, negative 5. There's another solution of this equation. And notice that these points are sketching out a horizontal line. You can hear my dog in the background. He's ready for his dinner, but he's going to wait. All right, so here we've got a horizontal line, y equal -5. And all equations of the form y equals some number are going to be a horizontal line. Other examples of horizontal lines. Oh, let's see. Here's a horizontal line that cuts through 8 on the y-axis. And every point on that line has a y value of 8. Y equal 8. Here's a horizontal line that cuts through -10 along the y-axis. Its equation, y equal -10. The x-axis itself is a horizontal line with the equation y equals 0, because every point on the x-axis has a y value of 0. Okay? Horizontal lines look like y equal a number. In our next example, x minus 2 equals 0. Let's move that 2 to the other side and write this equation as x equal 2. That's going to make it a little bit easier to analyze. Now here also we notice that the y variable is missing, and it's very simple. Maybe it's a little challenging, but it's actually very simple to generate points with an x value of 2. If we look at our x-axis, and we find 2 on the x-axis, and we plot that point, it is 2, 0. Okay, there's a solution. Now just find another point with an x value of 2, like maybe 2, 5. Okay, there's another solution. Find another point with an x value of 2, like maybe 2, -6. There's another solution. Okay, so y can be any number, but x stays constant at 2. And notice that we're tracing now a vertical line as we connect these points. Here we see the graph of the equation x equal 2. That is a vertical line. All vertical lines look like x equals some number. Okay, some other examples of vertical lines. If we sketch the vertical line through -8 on the x-axis, that equation is x equal -8. Now, if we graph the vertical line that slices through +8 on the x-axis, that's the graph of x equal 8. The y-axis itself is a vertical line with the equation x equal 0. All vertical lines have an equation that looks like x equal some number. Now this next page is a nice little summary for you to refer back to. As we look at forms of linear equations, standard form, ax plus by equals c. A, b, and c are real numbers. And I think we should say a and b, not both equal to 0 right there, okay? To graph, just find any 2 points on the line. A good choice is to find the intercepts by letting x equal 0 and solving for the corresponding value of y, or letting y equal 0 and then finding x. As a check, you can find a third point by choosing any value for either x or y that hasn't yet been used. And as an example, the graph of the line 3x minus 2y equals 6. Y-intercept 0, -3, x-intercept 2, 0, and here's a checkpoint 4, 3. If you've got an equation that looks like ax plus by equals 0, then this graph is going to pass through the origin. So to find additional points, you've got to get off of the origin. So choose a value for x or y that's not 0. For example, x minus 2y equals 0. You can see that it passes through the origin. Another point, 4, 2. And here's a checkpoint at -4, -2. If your equation looks like y equals some number, then draw the horizontal line through the point with coordinates 0, b. So whatever that number is, find it on your y-axis. For example, y equal -2, find -2 on the y-axis and form the horizontal line through that point. If your equation looks like x equals some number, it's going to be a vertical line through, okay, the point that has that number as the x value, okay, a comma 0. For example, the graph of the equation x equal 4, just find 4 on the x-axis and send a vertical line through that point, okay? Your graphing of horizontal and vertical lines is going to be the easiest thing to do as long as you recognize and know what you're doing, okay? Last example for this video, here we go, using a linear equation to model internet use. In the United States, the weekly time spent online in hours can be modeled by the linear equation y equal 0.96x plus 9.1. Here, x equals 0 corresponds or represents the year 2000, x equal 1 represents 2001, and so on. And we've got our source for the data for this equation. So let's just make some sense of things here, okay? Our x-axis represents the year, where x equals 0 is the year 2000, x equal 1 is the year 2001, and so on. On our y-axis, our weekly time online in hours. You can see there's a little jump here in our vertical axis as we skip a few values between y equals 0 and y equal 8. All right, here comes our question. Use the equation to approximate weekly time spent online in the years 2000 and then 2010. So you might think of things here in terms of a t-table if you'd like, where x represents year and y is the time spent online. Now the year 2000, okay, remember that x equals 0 represents the year 2000, doesn't it? Okay, and so let's use our equation. In our equation, replace x with 0. Well, 0.96 times 0 is 0, plus 9.1 is 9.1. Okay, in the year 2000, let's see, the weekly time spent online in hours was about 9.1. Okay, and that's this y-intercept point on our graph, isn't it? How about the year 2010? Well, in the year 2010, x is 10. So substitute 10 for x. Multiplying a decimal value times 10 moves that decimal point one place to the right. And adding there, we get 18.7. So let's see, in the year 2010, using 10 for x, okay? Then the corresponding value for y was, yeah, looks about right, about an 18.7. Okay, and that's 18.7 hours, isn't it, if we want to put our units in there, and 9.1 hours. Then lastly, here in part B, let's turn this around. During what year did the weekly time spent online reach 20 hours? So here we're given the x value, we're given the y value, hours, and asked to find x. So in our equation, y equal 0.96x plus 9.1, replace y with 20. Subtract 9.1. And then divide each side by 0.96. And there we've got x equal 11.354 and some other numbers. I'm going to say x is approximately 11.4. I'm going to round to the nearest tenth. That number to the right is a 5, so we're going to round up. So about 11.4. Kind of messed up my t-table there. 11.4. And let's see if this point looks like it sits on our graph, okay? For a y value of 20, let's come over to our graph. And then notice as we come down to our x-axis, that looks like it could be right about 11.4, doesn't it? So 11.4, 20. And another thing to notice here that we're finding the year, aren't we? And remember that 11 or 11.4 is actually during the year 2011, because it's the year 2011 until that number becomes a 12. So I'm going to summarize here and say that that's going to happen during the year 2011. Well, there's a nice application for our linear equations. In this video, we've graphed many linear equations. Good luck on these, and remember to show up, work hard, stay positive. Hang in there.